So welcome to the Stellar Open Protocol discussion. In these discussions, we discuss and plan for changes to upcoming versions of the Stellar protocol. Right now, we're focused on Project Jump Cannon, which will bring smart contracts to Stellar. In addition to changes to the Stellar protocol, it will also lead to the creation of a new smart contracts platform. And all of the discussion that we're having about this is being tracked and you can participate in it. Much of it is happening here on Discord in the Jump Cannon channel and the Jump Cannon dev channel. There are also a series of core advancement proposals or CAPs that relate to changes that would enable Jump Cannon or the new smart contracts platform. CAPs 46 through 55, I believe at this point. They're pretty modular, so each one sort of takes on an aspect of the changes that need to be made in order to bring smart contracts to Stellar. And we are working through those modules bit by bit and discussing sort of the segments necessary and the changes necessary to allow those segments to actually come to life. At some point, all of the work that we do will go through the normal process. In other words, CAPs are sort of put up in this GitHub repository that's linked to in the show notes. They're discussed here, they're discussed on a mailing list, and they're discussed in Discord. And after they sort of reach a point where they are stable, they move from being a draft into a formal acceptance period. Finally, they're accepted and implemented in a version of the Stellar protocol. And before that version of the Stellar protocol goes live, validators actually vote to accept it. Now, we are still fairly, well, we've actually made a lot of progress in sort of the Jump Cannon trajectory. But as of yet, the CAPs that we have in front of us have not been accepted. There's still a lot of questions. And today we will dig into some of those questions. If you who are listening actually have questions, you can leave them as text in the live chat channel. I'll try to keep an eye on that. We're certainly trying to move this discussion forward and have sort of the substantive issues come to light. So, you know, we may not be able to answer all the live chat questions, but we definitely will later if we can't answer them in the course of this meeting. So I think everyone is here, and I think we are ready to kick off. Today, I know that recently there was a new cap 55 fee model in smart contracts. I don't know if it just hit the mailing list yesterday. There were a few comments that came in. I guess I'm going to start by asking you, Nicolas, if we're ready to discuss that, if that's where we should start.
Maybe, yeah, like we can maybe like just go over like a quick overview of like what's going on in that cap, and then you know, like we don't have to go in details basically. So I'm not sure like we necessarily need to have like a lot of pre-reading basically as part of this. Is that good use of time of people?
Yeah, I think that sounds good. Also, Nico, if you can, you know, obviously a lot of these things are kind of like normal, quote unquote, in the world of crypto, but some of these are a bit more contentious. So I would like emphasize specifically like the contentious bits so that we can have a good old-fashioned argument.
All right. Let's see. Yeah, I mean, so do we want to start with this cap, or I think there was also like the events one that Siddharth open that is maybe a little more scope. I don't know.
Yeah, I agree. Let's start with the Siddharth one because it's less contentious, and we'll probably be arguing this.
Okay, great. So we'll start there. We'll end up at cap 55. Siddharth, do you want to
I can
kick it off?
I don't know if everyone had time to read the cap document. I actually made a fix of it this morning, but I can give a quick overview of it, and we can discuss after that. So I added this change onto cap 51, which is the host functions cap. I just added the ability for contracts to log data. So I added like a contract logs vector to the transaction meta. And as a part of this change, we also moved the transaction result into the meta as well. Both contract logs and transaction results are hashed, and a hash of these hashes are stored in the transaction result pair, which is how you would cryptographically verify them. And one change I haven't made to the document yet, but we talked about yesterday, was that we're going to add another contract log type where the logs are only emitted if there's an error. So that's a very high level overview. Are there any questions?
I guess like those logs, they are like logs that are like the equivalent to events in Ethereum.
Yeah. So the way it would work is, the contracts log whatever they want, gets sent to core. Core writes them the transaction meta, and then Horizon can serve them up in any way you want. So I would imagine that if you want to listen to a specific event, Horizon would provide that ability, allowing you to write applications that would hook on to specific events.
So one thing that I want to point out here is that it basically means that in order to sift through data coming in from Horizon as an ingester, you need to basically read everything, which may become a lot as the network grows in capacity. Ethereum has this concept of this Bloom filter that's included in every ledger header, so that you can actually get a strong indicator whether or not the smart contract that you're interested in, or the account that you're interested in, is actually included or has emitted events in that specific block. Should we consider doing something similar?
Yeah, I don't think I can't think off the top of my head why we wouldn't do like optimize like that area. So I can look into that. Like I don't think I don't think I see anything wrong with that.
Well, actually, I think it's kind of maybe like premature optimization type of situation. Like there are probably better ways to do it than doing this kind of arbitrary Bloom filter thing. Like, I can imagine, for example, like we have this meta stream. You could have Horizon tell core which filters it wants to apply instead of kind of doing it after the fact. And then the meta would be a subset of the meta. Like maybe like you're not interested in ledger changes, let's say. Or maybe you're not interested in classic transactions, like all those things.
Well, you're assuming a Horizon here, and I think that's like part.
Or there's always a consumer, right? Of like for
Right,
core.
but if you want something that's like an application specific consumer, which you do see in other ecosystems quite a bit. If I'm developing a dApp and I want to have a like a stream coming in of my specific information, why should I run a full blown Horizon rather than some sort of a light client that could just share logs that are specifically relevant to me?
And
Like
that's again like a subscribe model. I don't see why this is like part of this cap.
Well, I'm
Like-
not saying it's part of this cap, but I am saying like is there a place in the protocol to optimize for these use cases? Because we actually want more people to run nodes, and what we're doing here right now is that we're like really tying them down to like the Horizon model, which is consume everything, ingest everything.
No, like Horizon doesn't force you into consuming everything. You're getting the entire meta and then you filter it. Yes, like is the amount of meta being produced going to be a bottleneck in the even in the medium term? I don't think so. Like XDR is fairly efficient. Like I would like to see the actual performance problems before picking arbitrary type of filtering technology. Because I don't know what the use cases are. Like you're saying, there are events. Yeah, sure. Then you just keep events. It's a very small subset actually of the meta stream.
Is anything that we're adding here in this cap prevent us from adding a Bloom filter or other sort of strategies in the future? I don't think so, but
yeah, you can do any kind of filtering. I mean, I think the the place where I can see having an actual bottleneck in the future is the actual size of the meta. May get too large for like if you want to run a lighter node. But then we're getting into custom logic in core to kind of filter that somehow. And I think the best way to do it is actually like when you're producing it instead of trying to do it after the fact, like with Bloom filters.
Something that I don't see here when it comes to filtering is any way to filter beyond the contract. So like, presumably the contract, being able to filter by the contract is there because that would probably be in the transaction matter. But if a contract wants to emit a whole lot of different logs, how would an application filter on those specifically? Or is that just too granular, too micro?
So at the moment, the body is an SC-val. So if you wanted to do that, you would add the filtering in there. But I think we would discuss this. Like maybe that's not reasonable. We should add higher level filters like above the SC-val. Something we can consider.
Yeah, like right now,
little structure would make sense here.
Yeah, like originally, I thought we would do something like right now you have this log type, right? System or contract info, and basically if it's actually for both of them, you probably want to have like an actual event name, right? Like which is like a short symbol of sorts, right?
Yeah, I think that makes sense.
I would honestly look at sort of what the subscription patterns that you see in other smart contracting platforms are, because they have explored this space fairly extensively, and I think it's what a lot of the SDKs really lean on. Like if you're writing a dApp, it's fairly common for it to latch onto a bunch of subscriptions. So like however they're normally doing it, we kind of want to support those patterns.
Okay, yeah, I'll take a look at that.
Is there more? Anyone else have thoughts, questions, suggestions? Is it sort of clear what the next move is for you here, Siddharth?
We move on to Cat 55.
Actually, like there is something that I just thought about that I think from what I think Graydon was asking in terms of use cases, are there expectations, for example, that and that's related to this filtering question, that you want to have proofs of events that do not happen. So like positive proofs are easy, like with the proposal, you have like basically like you can prove that a given ledger had a specific event inside a specific generated by a specific contract. What if you want to prove the negative? That is that a specific event was not emitted in a ledger. Is that like the type of things that people try to do in other systems? But yeah, that's a question for to look into the what
I'll keep that in mind.
The use cases. Yeah.
55. Let's move on to it.
All right.
Ron, do you want to give the overview? Yeah.
Yeah. So 55 is basically like trying to layer fees on top of the various like resource metering that started to get introduced in the system. So it's kind of the problem is it's a little bit ahead of that because we didn't actually finish all this. Like I think we have the beginning of like gas metering, for example, in CAP 46, but there are like other things that are not covered yet. So yeah, this is so that's disclaimer. This CAP has a bunch of open-ended things. Let's see, and yeah, so like they are what the CAP is covered. There are like several aspects that are kind of maybe like more important to discuss. I think there's the first one around the classification of resources and having market dynamics based on those resource types. So this is an area where if you look at other blockchains, it's actually a mix of things. Like some systems, historically started with just like Ethereum, just like gas as being the gas. So gas in the context in this context, meaning the kind of this metric, right, that allows to kind of count the cost of a to execute a transaction, and cost here is kind of pretty loose in terms of definition, like mostly computation. But when you do when you load like a ledger entry, like when you access ledger, you also pay for gas, and then yeah, so you have like gas cost, which is this aggregate metric, basically of multiple resource types. And then more recently in Ethereum, there have been discussions around other types of resources that are kind of interesting, such as bandwidth. And then you have basically you have a kind of a funny crossroad there. That is, do I want to have a market for each of those resources, or do I want to kind of generate like a composite market for those? So like you have like I think in Polkadot, what they do is they put the aggregation. The way they do it is with a polynomial function. So basically, you take all those resource types and then you assign them a weight. Actually, it's not even. I think they are linear. It's a linear thing. And then yeah, you combine all those things and you get with your synthetic. I don't remember how they call it. Weight, I think in over there. But like yeah, like that's a way to kind of compute this aggregate gas. So the challenge. So talking about challenges that comes with those aggregate models is that it's actually very hard to discover price of things. Like an example is if you take a transaction that does a lot of I/O and very little compute, that is competing with a transaction that does very little I/O but a lot of compute, like with those aggregate functions, if try to pay like 10 times more, for example, bid more, right, for one transaction, you don't know if you're signaling that your I/O is what you want to prioritize, or if it's your compute that you want to prioritize. So yeah, so it basically causes the overall prices to have like this uncertainty in terms of like what should I bid. So that's kind of one of the problems with those kind of aggregate metrics. So with that said, with Jump Cannon, like one of the things that we are doing is we have a very clean separation between the different resource types. So I/O, for example, when we read or write to the ledger, those are done basically outside of the main execution. Like you can think of before applying a transaction, before executing a contract, we load all the ledger entries that this contract needs, and then it does its thing, and then at the end, it produces potentially side effects that will be applied as like a post step. That's kind of a logically like the way we can think about this. And the opportunity here for us is that because we have those kind of completely separate, we can actually and we also do it because of performance reasons for parallelism. But like because of that, we can actually express those markets separately, and we can therefore, I think, have like cheaper fees overall because you can price things properly. So you don't have to do like to kind of artificially inflate, for example, inflate the price of reading data from the ledger because compute happens to be expensive, which kind of would happen with the aggregate model. So in the proposal, what I'm doing is actually I have like three really buckets for fees. So one is for gas, which is the compute time. You can think of it as execution time in our model, really, because like I said earlier, we have a full separation between I/O and execution. So this one you can bid. Second market that I have in the proposal is for reading and writing to the ledger. So here there is actually a competition for there are so many there's like you have like constraints, right, in terms of number, like the bandwidth to the disk subsystem, both in reads and writes. So because of that, you have to have like a market for that, and it is separate right now. And it is separate also because there's a interesting fee model for writes that I'm going to talk about later. Let's see. And the third category is actually something that is not a market. It's not really a market. There are dynamic fees for what I would consider like commodity on the network. So things like producing meta or data that ends up being stored in archives. Those do not, there's no reason to have like really competition between transactions. Instead, we have like limits per transaction. Like basically we say you can only produce, I don't know, like 500K or something of meta, right, for a transaction. And then that's your limit. And then two transactions are actually not competing against each other. So there's no need to kind of have a market dynamics there. So there are actually a few of those resource types, and because there's no market, you can actually aggregate them. So they end up in one big bucket of like deterministic fees, basically based on the current state of the ledger plus like the actual transaction. So those are like the three fee categories that we have in this proposal. Any question at this point on this? I've been going back and forth actually on this, should we or not separate fees? We could go with one, like I said, one market, but I think it pushes price quite a bit too much for like cheaper, whichever resource will be cheaper, which is hard to predict.
Do we anticipate that this will be difficult for users to reason about, to like understand these different types of fees and to think about how to set them?
So yes and no. I think that's actually one of the things that's kind of interesting is that when we have already in the system a strong dependency on a pre-flight mechanism. So like before submitting most transactions to the network, they will have to go through a pre-flight endpoint. The pre-flight is the thing that basically will allow people to compute gas, for example, to estimate gas for a transaction. In addition to that, let's see. In addition to that, yeah, we have like I was saying, like certain fees that are like more like dynamic because they're based on the current ledger. Like for example, like a bunch of those things that I was saying are like the price of storage in archive. This is voted by or determined by the validators. So before submitting a transaction, you have to know basically what those parameters are. Yeah, so as part of the pre-flight endpoint, you basically get an estimate for the minimum fee for those categories. Well, in the case of the non-market-based resources, the minimum fee is basically equal to or very likely to be equal to what you need. In the case of where you do have markets, it's more like today where you have to decide how much do you want to overbid based on that, because the minimum fee doesn't necessarily translate to what the market is willing to pay. So you have to look more at historical data. But this is like something we can, that like endpoints can, like Horizon can expose, right? And having them tracked as separate resources in terms of historical price allows to have actually something a little more stable, I would imagine, than if it was like an aggregate. I think the complexity from multiple markets comes from, I mean, one of the implications is actually when we construct, validators construct a transaction set, it's going to be a kind of multi-dimensional knapsack problem, which is not great. But that algorithm would not be part of the protocol. It's more like it's if you have like 5 seconds to produce a block, there's so much compute you can span in assembling the perfect transaction set.
Yeah, to answer your original question, Justin, at the end of the day, the wallets should have an easy way to present an estimated cost in XLM, a currency that they can understand, and they can tell the user, hey, like, this is how much more you can propose for that. Like, they don't need to actually understand the mechanics of how this works.
Yeah, it's true that when you overbid, right? Like you're doing, for example, you say I want to pay like 10% more than whatever happened in last few ledgers. That 10%, you can put it, I imagine pretty safely across like those different resource types, like the ones with markets, because the assumption there is like they are priced accurately. But I imagine that more, like if you want to really save, it's hard to predict, but like if there are like some of those, like gas, for example, becomes very expensive, you don't maybe you don't want to be as aggressive on the other resource types.
Can I jump in with a couple comments?
Yeah.
So I guess one, it's I guess high level, it's not clear to me what this adds over for having like a multidimensional optimization problem over the one-dimensional one. And the reason is that sorry, I haven't thought about this all that much. But the reason is that like when at least in the current execution model, sort of everything executes at least everything in one lane is going to execute sequentially, right? And so the main like resource that's truly limited in like a block is time, right? And it's like unless there's some sort of weird interleaving going on between like transaction executions, that's sort of the one-dimensional resource that we have to optimize anyway. And so it's not clear to me why like your example of like a transaction that does lots of IO versus one that does lots of compute, well, both of them are going to take a lot of time if they're using a lot of one resource. And so it's not clear to me that at least in the current execution setup we have, that it's we gain by sort of allocating some I don't know resource to like IO versus some to compute, as opposed to just like looking at the whole picture of like the total end-to-end time of the transaction. That said, it does seem like it'd be good to like have some kind of like price discovery mechanism for different resources, and certainly like you want like an overall limit perhaps on like the total number of ledger entries. And so I don't think sort of thinking off the top of my head, I don't think it's incompatible to have like a one-dimensional like gas market and then like sort of price markets on each resource, in the sense of transactions could bid like for the amount of resources they want to use and like the fee per resource, and then you do some like filtering step, but that's sort of thinking very much off the top of my head. I don't think we necessarily I guess high level, I don't think we necessarily have to go to the full multidimensional optimization problem.
That's possible. Like it just looked like from historical kind of experience, right? Like IO is a huge problem, and trying to model that as time is actually making it's actually a disservice in a way to the network, because you have like very expensive from a like disk point of view, right? Like something that's going to suck your disk resources that now stole all your cores, right? In a parallel execution model. Like stole as in, because like I said, we do all IO early on, and if you're actually maxing out your drive, then you're just stuck.
Right. I mean, it makes sense to have perhaps a limit on overall IO, I guess.
Right. And then there's the other aspect, actually, and maybe if we can, like I don't think we're going to necessarily like close on this multi-dimensional thing, now, but like there's the other aspect of ledger size and writes that is actually another kind of key thing in there that I guess makes IO a little more special also.
Nico, just to go back to Jeff's point, like I understand that why IO needs to be priced significantly higher than the compute operations, but I don't necessarily understand why it needs to have like its own market.
So the pricing, right, that you have is the minimum price. It's not the market price, right? Like when you market price is like in the ideal, like what is described in the cap is trying to be closer to like the ideal situation where you can actually construct a transaction set that's going to basically be like right at the edge in terms of the capacity that you have on your actual underlying hardware, so like CPU and IO for disk. If we lose that visibility, then you may actually allocate too many transactions to compute, when then you don't have like basically like the kind of natural way of having a transaction compete against other transactions that are paying for expensive stuff. That's kind of what I'm getting to. Like if you have like what was it, like a good example would be like yeah, I don't know which one of those resources would be more expensive, but they're not going to be in the same order of magnitude. Let's say like compute is the one more expensive at a given time. So you have to pay like 10 times more, right? Or 100 times more than the minimum fee for compute to get into the ledger. But your storage price is also kind of expensive, and by bidding 100 times, you also bid 100 times on storage, and you're basically overshooting quite a bit compared to the ideal model.
Yeah, I think the general point here is just that you cannot that in reality, it's not the case that there's just time when a transaction is executing. There are two different resources, and there are different contention patterns on them, and you can't trade one for the other. The system does not actually trade one for the other. Like if I for example submit 100 transactions, every one of which is doing incredibly CPU expensive stuff, that doesn't saturate the I/O system, and there's still no contention on the I/O system. Whereas if I submit 100 transactions that are just doing I/O and they're doing no CPU, that doesn't saturate the CPU. So they are really two separate resources, and the point where one of them hits a limit and can no longer do transaction processing, it doesn't represent a limit on the other, and vice versa. And so you can't trade between the two of them from a market perspective.
Sorry, I'm not quite following something. Didn't we say earlier that we were going to do like all of the sort of disk reads first and then do the executions? Right, so that if we have a lot of disk reads, then we have less time for execution. Right, and sort of vice versa. But I sort of understand that they're not like directly tradable, but they seem correlated or anti-correlated.
Well, they're different devices. So like
Right, but I'm using the disk and then I'm doing the CPU, right? I'm not using it at the same time. I mean, like, sure, there's different buffers and things, but
yeah, sure, but the execution characteristics of each of them are different. So you use everyone uses the same disk, and then everyone sort of farms out to multiple threads. I feel like we're talking past each other. I mean, yes, one goes in order of the other. The two of them do get added together in order to represent the total time, but you can't trade time on one of them for time on the other. That's what I'm saying.
I think I'm not quite following, but that's okay.
Nico, are there any other networks and fee systems that introduce the split or that work similarly?
Those are like the two, like the execution time and like compute, right, and disk are like the two big things that I isolated. Like the rest, I figured it is probably not needed, so I kind of put a flat fee for the other ones. Like basically, like in the proposal, I'm basically saying like we're okay with, if you want to have like something that like if you have a transaction that is very important that happens to emit a lot of matter, for example, well, you have to just overbid like crazy on your compute, even though you're not really, that's not what it's about. You have to find a way to get it prioritized. Let's see. We
Nico,
talk about
another thing I kind of wanted to talk about here is in your proposal, you're talking a fair amount about state expiry.
Yeah,
Brayden,
that's
before we go into state exploration, which I know is a big topic, I'm still trying to reason about like the kind of like the wallet experience and user experience of having these like multiple dimensions for gas. Like, what is the expected behavior here for wallets? Like,
so
what
to
do
be
they?
clear, right? Like Tomer, like single dimension or multi-dimension, from a wallet point of view, if you want to estimate, it's the same problem, right? Like it's like in the single like a cost model, like you aggregate everything into one. You have to actually you have like a function, right, that just aggregates, but you do have to estimate your bid for each things. So it's not it's actually like a funny thing that that you have, except maybe the tools you have for discovering price are not as great because it's all implicit.
Okay, so a wallet can do a pre-flight, can tell me like the expected cost. I can, um, you know, bid over. Um, but how do I know how to divide that between like the compute and the I/O?
But like it's the same in, like I said, like it doesn't, that question is not a question around multi-dimension versus single dimension. Because that like if you want to like if you want to say like I want to pay 10% more for on top of the market rate, right, for storage, let's say, because that's where there is contention. You have to know that that's exactly what you have to have. Like you have to have the market price for storage. If you just layer like 10% flat on everything, you're just going to overbid, which is maybe okay, right? Like for some people, if the fees are relatively low, what's the difference between half a lumen and 2/3 of a lumen or something? I don't know. But like historically, we've seen that like in some situations, people are are bidding very high on certain for certain patterns.
It would be great to maybe, and forgive me if it's already in the cap, but just like understanding what is the what's the expected wallet strategy or client strategy here, when like in terms of user experience, like what do they present to the user, and what what kind of input do they expect from the users?
Yeah, sure.
Okay, let's talk about state exploration. Nico?
Or is it state? Well, so state exploration, yeah, goes kind of hand to hand with the model that I have there for storing data on the ledger. So like in the proposal, it's basically like there are two parts to it. There's the how do you model a write, and as in, so write can be a create a ledger entry or an update. And how does it work? How do we have like the right price basically for the cost of storage? So in the proposal, what I did is I basically used as an approximation for the cost of storage the bucket list size. So like the some basically like the ledger is organized into those 19 buckets. I think it's 19. And then if you do an update or a create, you basically append that to the very first bucket in the bucket list. So that's how basically like based on the size of the total size of the total size of the ledger, I allocate like a price function that kind of looks like an exponential from far. Like basically, it starts with a slow slope up to some number. Let's say you say, oh, like validators here are kind of determining those parameters, but like you can think of it as validators say, oh yeah, right now we are running on drives with I don't know, like 25 gigs or 50 gigs of space, right? And they're going to basically set parameters such that they don't have to kind of buy new drives, like if there's too much traffic. So the price function is basically looks in this case like you have like your normal slope that goes to like, I don't know, let's say you have 100 gig, and it would be like, I want to use maybe like the first 80 gig at a rate that's going to be like a good rate, but not like overly aggressive. And then the last 20 gigs, I want to really slow down like the growth. So that's why it, like from far, it looks like this hockey stick type of shape, right? Like an exponential. And that's kind of the model for pricing, growing the bucket list. So you have that that's for writes. Then the problem is that this is only like this is like saying, okay, you can add to the bucket list, but then like and by the way, like if you delete entries, eventually those get collapsed into the buckets, and so the bucket list shrinks. In that model, a delete, you still pay for a delete actually, because a delete is actually adding a little bit of data to the bucket list. So that's like first thing to note here. And then, yeah, what I wanted to get here is as a kind of more like a desired property is that I want the price of storage for people to kind of be the same for everybody, regardless if they signed up for, created an account like 2 years ago or, in 5 years. It should be over time same cost. And there should be no way to do like to have like a free ride on the ledger, right? Like, so you shouldn't be able to have like store, I don't know, like NFTs, like JPEGs, whatever, on chain. You pay for this when storage is cheap, and then now you have like something that is cheaper than even storing in AWS, right? Like that doesn't make any sense. So with that said, there's then a need for having some way of kind of resetting, in a way, the price of storage over time. And the mechanism that I use there is state expiration. So state expiration here means that you have to basically pay for market price of storage to maintain a ledger entry on the like live in the ledger. If you do not pay for this for your brands, basically, you get purged. That's kind of the choice that I made in this cap. There are a bunch of other ways that can be done that are actually mentioned in the cap in the other approaches. But like the reason this kind of works with the other mechanism is that basically, like if you set a policy, for example, by default, you have to pay rent like refresh every year, let's say, and then you don't pay your renewal after a year, yeah, the data gets deleted. And yeah, so there's this kind of constant churn, I guess, on the ledger, which is kind of a new pattern. And that constant churn is basically a way to guarantee that everybody in the last year has been paying basically something that is market rate.
How long do you expect how far in the like when I create a ledger entry, how far is the maximum expiration date that I can choose or that will get chosen for me in the future? This stuff isn't, as far as I can tell, it's not specified in the cap how that works. So
right. So right now the cap, what it says is that you do not. So you can renew indefinitely, right? Like the renewal window is determined by validators. So that's why I said it's like like you say, every year you have to pay rent, right? And then every time you write, you do an append, that append is valid for a year, right? That's the model.
Isn't there a natural trade-off between like renewal time and like fluctuations in this price of storage, or are we expecting like this storage cost to not increase too quickly?
Well, it depends. Like what we've seen on the current network is ledger size has been increasing actually rapidly over the last few months because of like some strange token activity, which is not entirely. I mean, it's not. I mean, there are a combination of factors. Like one is like just price of in crypto assets going down, but also like when they were still pretty high, you had like an incentive to create more crypto assets. So basically those things kind of cancel each other, and the growth has been pretty significant. So I would say like seeing a growth rate that takes you to something that where you want the market basically to kind of get to an equilibrium, right? Like where like you do not have like those weird use cases appearing on the network if they are like cheaper than. Right now, I think on the network, the problem we have is we're cheaper than AWS in some situations.
isn't there a trade-off here between, well, not necessarily a trade-off, but isn't there a consequence here that people will have to go and touch their data from time to time, and people are procrastinators, and like let's say that like the expiration date is 1 year in the future or something. Everybody at the end of that year then has to go and touch all their data, and there's going to be a huge logjam to get it done.
Well, there would be a logjam if everybody creates their stuff at the same time, but that's not the case. It's going to be, like basically like the thing that expires in a year is the whatever happened today, right? Like at a given date.
Right, but I mean, like, imagine that today you have a day with like a lot of activity. Like you can look back historically at Stellar's history, and there are periods when there were like lots of token creations and stuff. There are days when there's hundreds of thousands of ledger entries created.
And then abandoned.
Well, many of them are abandoned, but like you could imagine a world where they're not all abandoned, right? And then what happens a year in the future?
Well, no,
Yeah,
well,
people are incentivized to come back sometime between here and then. I don't see this as any worse than the fact that we have to handle load spikes in general. Yeah, I mean we have to handle load spikes, and load spikes may get replicated, but
yeah, like what so what I sketched or what we sketched actually in the cap, which is just a more of a strawman type of thing, because I'm sure we can do better than that, is we actually are kind of ensuring that you do not have like giant spikes. So I think the spike would not be because of situations, John, like what you mentioned, because actually activity from today, if you have like a linear, like a translation, right? Like an actual just shift, right? Like all this activity gets translated exactly a year from now, you don't have a problem. I think it's just like additional cost of running a validator, right? Like it's you say, okay, I need to, when I set my limits, right, in number of writes, I actually have to think about, well, actually my capacity in writes is half of what I can add to the ledger, because I also need to delete, right? But what can happen is more of a if we have different expiration times, which I actually kind of briefly talk about there, is that if you have different expiration times, you can have actually different dates that end up expiring at the same date. And for those type of situations, you have to have an algorithm that kind of smooths things out, and that doesn't actually cause the system to kind of create a gigantic spike, at specific dates.
So we don't have a lot of time, but I just want to ask, like the biggest question I think that there is like, what's the expected behavior here? Like, these ledger entries are representing financial instruments. Let's say assets, just for simplicity, even though we have like a standard asset contract. And I'm, hodling on shares of something. What is the expectations, or what's the expectation in terms of, like, am I supposed to, like, once a year, like, come and touch this? Is like the operator of this financial instrument supposed to do that for me? If if you look at various common immutable contracts like Uniswap, and I'm holding on like these Uni tokens, what's the expectation here? Like, who's gonna touch these for me?
Right. So in the cap, I actually let this kind of flexible. Like there's actually a special host function that you can call, that is basically a rewrite equivalent to like a rewrite ledger entry, so that you refresh that expiration time.
Yeah,
and anybody can do that, right? Like it's not
I understand
privileged.
that anyone can do that, but who do you expect to do that?
Well, it depends on the type of users, right? Like power users, you probably don't want to do it themselves. Like other situations, if you're like you said, like this very passive type of person, maybe you should pay somebody to maintain your stuff if that's what you really want. In other situations, I suspect if people are not active, they probably should just be using centralized infrastructure, like contracts or whatever that are a little more centralized.
I think Tomer's point is that there's a free rider problem here. Like, imagine that all the people in this room are using a single contract, right? Like, which one of us should touch it? All of us have an incentive to wait until the last second and play chicken and hope that somebody else touches it.
For a shared contract, I think that well, if it's a shared goodness, like
just
I
a
mean,
second. So that's not what I asked, John. I assumed that like each of us will have like our own ledger entry within that contract. So maybe did I not understand correctly?
I think Tomer's concerned about people's money vanishing into thin air, which is completely reasonable. These are balances, and we're just going to delete them. That's not super great.
I recall there being a proposal to like have but what happened to this? Like when you have a ledger entry deleted, it like gets dumped into like some kind of Merkle trie, and you store the root of that trie, and then like when I want to bring it back, I can like bring in a proof that this is what the state was.
Right. So this is actually in the appendix.
It's in the alternative section.
Okay. So there is actually a very detailed proposal in Ethereum for Ethereum v2 about this. So the complications from this archive approach is when you want to. So like restoring is actually like trivial. Like I said, like you have like maybe a way to do like to basically store that entry inside a Merkle trie of sorts, right? And then you just need to provide the proof for that. The complexity comes from when you want to create an entry, because you have to prove that that entry doesn't exist in historical data, like that was actually archived. And that gets really nasty very fast.
Right, sure.
But like that does, like not wanting to do that doesn't address Graydon's question. Like, what do you do if your money gets deleted?
It's an event like if it's like with an issuer, it's like today if you're on the Stellar network, if you're sending back to the issuer, you basically burn it. You can ask the issuer like, hey, sorry, I didn't mean to do that, but
I didn't burn it.
But like, what if it's not like, an off-chain issuer that you can appeal to? Like, what if your Uniswap LP tokens get deleted? What do you do? Who do you complain to?
it's tough. Yeah. Those are the rules of the network.
Wait, but that's not a great solution long term, right? Like we're gonna have a lot of people who like lose their phone or something.
Consider the alternative, right? Which is infinite growth of a ledger with infinite price. Which one do you prefer?
I mean, like, objectively, like, if somebody had $1 million of like Uniswap LP shares get liquidated, it would have been better to pay for $1 million of storage. So
that one person, yes, but like, what about everybody else? And that person with $1 million, like if they have that, it's kind of like key management. Like you have procedures to make sure that you don't lose your $1 million.
Yeah, it is currently the case that people with $1 million balances can in fact lose them because they can lose their keys. So there is something to appeal to here. Like it is actually possible for you to lose money just by misusing the system. But
what about the other end of the spectrum, though? Somebody who doesn't have $1 million, they have a small amount of their balance, and they're just constantly eating that up by paying these fees to keep their balance alive. I mean, it sort of reminds me of like bank accounts, where you're like, bank accounts just disappearing because you're paying all these fees.
yeah, they do eventually disappear. If you put $5 in a bank account and then wait for 20 years, it'll go away.
I mean, this just points to, you're not storing your balance in the right place. Like this is shared infrastructure. Like if you don't use it, you lose it.
But Nika, you can't just like ignore the entire industry that we're in, and I'm not pretending that this is not a problem. Like people are overlooking this problem, but it's I think it will be really difficult to bring people into Stellar, telling them.
So this is the way it works in Solana, right? So is Solana a failure?
No, it's not. Solana doesn't actually do any of this right now.
They have rent.
No, they don't. They literally don't charge it right now. It's a to be done in the future feature that no one wants, so they're never actually going to get around to doing it.
They have an infinite ledger in memory.
They charge you money to allocate space, but they never actually reclaim it. There's no active garbage collection process.
So we're over time at this point, and I think that means that we have to stop. I mean, I know that this is an interesting conversation, and seems like there's a lot to say about the concept of expiration, but I think we'll push it to next week's meeting and hopefully have some of this discussion on the Stellar Dev mailing list and here also in Discord in the various Jump Cannon channels. So if anyone is watching and has thoughts about that, feel free to join the Stellar Dev mailing list or to chime in on the Discord here. We'll continue to share work and ideas and conversations, debates as they happen, and we will see you here again soon. Thanks, everybody.